let us consider different ways to describe a system, because each property is a relevant characteristics which describes a system, but the way we describe a system depends on the approach we have. For example, our viewpoint or our approach could be microscopic as against macroscopic. So let us look at the microscopic approach. The microscopic approach is the typical approach of a physicist or a chemist. Okay. Here we assume that a system is made up of a collection of a large number n of particles. What is the order of n? Very large, 10 raised to 20, 10 raised to 25, of the order of the Avogadro number. And each of these particles is moving randomly during the course of a system. Particle may move from one part of the system to any other part of the system. So each particle will have a position and will have a velocity, and the position of each particle will be a function of time. The velocity of each particle will also be a function of time, and that means suppose there are a large number n of particles, we will have to specify n positions and n velocity vectors, each one as a function of time, and consequently this leads to large number of pieces of information, and it is not so easy to handle. So hence, a consequence of this, some type of averaging is used, and this leads to the statistical approach, leads to statistical thermodynamics, statistical mechanics. This is the statistical approach. We are engineers, and engineers, in particular mechanical engineers, generally do not need to use the microscopic approach. We are very happy to use the macroscopic approach. So our viewpoint is macroscopic and not microscopic. Here we will consider each system to be a continuum, and the advantage of this, considering each system to be a continuum, is that we need to have only a few properties, sometimes as few as 2 or 3, sometimes perhaps as many as a dozen, okay, but never more than a reasonably small number. And because of a few properties, we have a small number of variables, and hence a small number of equations, both of which are advantageous for proceeding with the solution of a problem. So small number of variables means small number of properties, and small number of equations means a few laws and other relations that we have to work with. This approach is also known as the phenomenological approach, because here we are going to study the phenomena which take place, generalize those phenomena as our laws of thermodynamics. It is also known as the classical approach.